Hello everyone, in this video we are going to solve today's LeetCode problem of the day, that is kth symbol in grammar. The difficulty of this problem is medium and this is based on recursion. Okay, let's read the problem. We build a table of n rows. We start by writing 0 in the first row. Now in every subsequent row, we look at the previous row and replace each occurrence of 0 with 0, 1 and each occurrence of 1 with 1, 0. Okay, let me tell you what question is saying. There. The question is saying that we are given two integers n and k, okay, and we need to find, and it is given that for n equals to 1, the output will be 0, or our string will be 0, or grammar will be 0. And for every next, for example, n equals to 2, what we need to do, we need to find grammar for n minus 1, for here n equals to 2, so grammar for 1 and replace 0 with 0 1 and 1 with 1 0. Okay, we need to replace 0 with 0 1 and 1 with 1 0. This is our condition. And another character k is given. Wait, we learn about k after some time. For n equals to 2, what we will do? For n equals to 1, we have 0. What we need to replace? 0 with 0 1. For n equals to 3, what we need to do? Replace this 0 with 0 1. Replace this one with 1 0. For n equals to 4, what we need to do? Need to replace this 0 with 0 1, this one with 1 0, this one with 1 0, and this 0 with 0 1, and so on. And we are given k, and we need to find kth character in the nth row. For example, here n equals to 4. Let's suppose if k is given 3, so we need to find what is present at k equals to 3. This is k equals to 1, this is k equals to 2, this is k equals to 3. So here it is 1%, so we need to return 1. Here k equals to 4. Okay, so we need to do that. So this is a simple observation based question. Let me write it clearly so you can observe this. N equals to 1. For 1, what will be our output? Our output will be something like 0. For 2, what we can do is we can write 0 1. For 3, what we can write? For this 0, we can write 0 1. For this one, we can write 1 0. For equals to 4, n equals to 4, what we can do is we can create 0 4 0 1, this one for 1 0, and this one for 1 0, again this 0 for 0 1. From here, you can learn, or you can observe one thing. What is that? You can observe that the half of the string here, see, this is present, half of the string is simply copied of n minus 1. Here n equals to 2, the half of the first half of the string is just copy of the n minus 1. Here the n equals to 3, it is the copy of, half part is the copy of n minus 2. Well, 2. Here n equals to 4, the half part is the copy of n equals to 3. And here the other part, what is the other part? The other part is just just negation of this part. For example, here see, here if it is 0, here we get 1. Here it is 1, we get 0. Here 1, we get 0. Here 0, we get 1. Similarly, assume in this question the half part is same, 0 1. For the next part, here it is 0, then we get 1. Here it is 1, we get 0. Okay, hope you understand this. This is a completely observation based. You need to observe. Okay, so देखो, the half part n equals to 2. This is the copy. The next part is the inverse. Here the n equals to 3 half part is copy, and the next part is the negation of n minus 1. Okay, so what we can observe from this is this. From this is for n equals to Wait. If we need to solve for n comma k, we need to find, we need have two conditions. If k is less than or k is less than or equals to mid, that is k lies in the first part. Okay, so our answer will be just solve for n minus 1 comma k. Why? Because the first half part is just copy. So either we get this or we can solve this, we get the same answer. And else, if k is greater than mid, so here we get here. So what we need to do, we need to negate. If we get 1, we need to convert it to 0. So we need to do not of solve n minus 1 comma, and what we do, we need to find this. So what we need to do is we need to subtract k minus mid, hope you understand why. Because let's assume this is 1, this is 2, this is 3, this is 4, this is 5. What is 5? 5 is just negation of 1, and here the length of the string is 8. So what we need to do is we need to divide 8 by 4. 8, we need to subtract 8 minus 4. That is 8 minus, okay, wait. Huh. We need to do, if let's assume we need to find this 5, for this 5. What will be the answer for 5? For 5, it is 5 minus 4. That is 1 ka negation. For 5, it is the negation of 1. Wait. And what is this? This is k equals to 6. What if we want to k equals to 6? We need to find n minus 1 ka second. So how we get second? We get k minus mid ka negation. Okay. So how we get the mid? So for getting the mid, so here we need to find the mid. So for finding the mid, what is the mid? Here the mid is this, here the mid is this. So finding the mid, we need to find the length of the string and divide it by 2. Okay. So how we get the length of the string? So here you observe for n equals to 2, n equals to 1, what is the length of the string? That is 1. Here length is 1. So how we get? We can write it as 2 to the power 0, that is 1. For length equals to 2, what is the length of the string? That is 2. So we can write it as 2 to the power 1. For 3, what is the length of the string? 2 to the power, length of the string is 4. We can write it as 2 to the power 2. Okay. For length equals to 4, for n equals to 4, what is the length of the string? That is 8. So we can write it as 2 to the power 3. So from here, you can observe that the length of a string will be length of a string of n size equals to, let me write it here. So let me write here. For length equals to length for n. What will be the length? Length will be 2 to power n minus 1. Okay, there go. For length n equals to 1, what will be the length? Length will be 2 to power 0, that is 1. For n equals to 2, what will be the length? 2 to power n minus 1, 2 minus 1, that is 1. The length is 2. For n equals to 3, what will be the length? 3 minus 1, that is 2, that is 4, and so on. So we get the length. So how can we write the code? Let me write the code. For example, we need to find this, solve this. If the base condition is given, if n equals to 1 and k equals to 1. So what we need to do? We need to return 0, that is given, and else what we need to do? We need to find the mid. How we get the mid? For mid we need to find the length and then divide it by 2. So how we get the length? That is, we can find it by math dot power of 2 comma n minus 1. By this we can get the length and then divide it by 2. We get the mid. And what we need to do next? If k is less than equals to mid, then what we need to do? We need to return solve for n minus 1 comma k. Else, what we need to do? We need to return not of solve n minus 1, and for this we need to do k minus mid. Okay, so for not, what we can do is we can subtract 1. Why? If, assume, if we get answer 0, what we, and if we want to convert it 1, convert it to 1, what we can do? We can subtract 1 minus 0, that is 1. But if we get 1 and we need to convert it to 0, that is we can do 1 minus 1, that is 0. Okay, so we can replace this not by 1 minus solve. Hope you understand. Okay, and this is our code. So let's code it into the our ID. Okay, sorry, in the LeetCode problem. Okay, if n equals to 1 and k equals to 1, return 0. Int mid equals to, here we find the length, and for mid we divide it by 2. And if n is less than equals to mid, what we need to do? We need to return, what we need to return? We need to return kth grammar n minus 1 comma k minus 1, sorry, k. And if this is the not case, then we need to return 1 minus kth grammar of n minus 1 comma k minus mid. Let me run this code. Wait. Return kth grammar n minus 1 and k. Sorry, here we need to write it as k. Sorry, here we need to write it as k. Why? Because we find the kth character. Okay, it passes all the test cases. Let me submit. So here it get accepted, and it is faster than 100% Java submission. It takes time 0 milliseconds. So let me discuss its time and space complexity. So what will be the time complexity? Here, here, where? Here. What will be the time complexity? Let's assume here for n, what we can do? We can call n minus 1. For n minus 1, it get calls to n minus 2, n minus 3. So here, yeah, either this condition runs or this condition. At there is no time where both the condition runs. If this condition runs, then this will not run, and if this will run, then this condition it will be not executed. So, and every time we get decrease n by 1. So in worst cases, the n runs to the n times. So our code runs n times. Why? Because if n equals to 5, then first we go to n equals to 4, then 3, then 2, then 1, and so on. So its time complexity will be big of n. And what about its space complexity? We doesn't use any extra space, so its space complexity will be big of 1. So our time and so our time complexity of this code will be big O of n, and what about the space complexity? It will be the big O of 1. Hope you understand the code and the logic part. Please like, share, and subscribe the videos. Thank you.